Good morning, children. Today I am going to explain you how to find inverse of a matrix by adjoint method. Okay, so this matrix is given to us. We have to find its inverse by adjoint method. Okay, so inverse exists. We know that inverse exists if and only if it is a non-singular matrix. So let us check the determinant. So find out the determinant value of this matrix, and now expanding along the first row, this is 2 into minus 1 minus 0. Okay, so minus 1 into next term is minus 1 into 4 minus 0 and 3 into this is 8 minus 7. Okay, so we get this value, determinant value, as minus 3. It is not equal to 0, hence matrix A is non-singular matrix and A inverse exists. So whenever we have to find the inverse of a matrix, we will check the determinant and it should not be equal to 0. So inverse exists. Now we are going to find the inverse of a matrix by adjoint method. So in this case, we will find the minor and the cofactor. So first of all, find the minor of this matrix. See how to find the minor of this matrix. For every element, we have to write its minor. Minor is denoted by M. So M11, this is the minor of the first element, first row, first column element, that is 2. And skip this column and the row element, then solve the determinant of the remaining terms. It is minus 1 minus 0. So minor M11 is minus 1 minus 0, it is minus 1. Minor M12, skip this column element and the row, find out the value of the element of the remaining element of this determinant. So 4 minus 0. This is M12, it is 4. M13, this is 13 position, element is 3, skip the column and row, find this determinant. It is 8 minus 7. Okay, so in this way we get the minus. For M21, we will skip this column and row. So skip this row and the column, first column. This will be 1 minus 6. So similarly, you can find the remaining minus. So these are the minus of the elements of the matrix. Then find out the cofactors. I have already explained how to find the cofactors. This minor, find the sum of I and j. So cofactors are denoted by A and A11. Sum is even number. We'll write the minor as it is in the cofactor. If the sum is odd, we will change the sign of the element. Okay, so in this way we get the cofactors element. So these are the cofactors. For every minor, we'll find cofactor. Cofactors are denoted by A, capital A. So these are our cofactors. So we get the cofactor. Now we'll write the cofactor matrix. So write the cofactor matrix. This is minus 1, minus 4, 1. In the first row, minus 1, minus 4, 1. Then in the second row, write these elements, 5, 23, minus 11. 821, 822, 823. These are the second row elements. So here it is 5, 23 and minus 11. Similarly, write down the third row element. You will get this cofactor matrix. Then find its transpose, and its transpose of this cofactor matrix will be the adjoint matrix. This is called as adjoint matrix. So children, don't forget to take the transpose of the matrix. Most of the time students forget to take the transpose and hence the problem becomes wrong. So be careful. Don't forget to take the transpose of cofactor matrix. So its transpose will be adjoint matrix. Minus 1, minus 4, 1. This is our first row of cofactor matrix. It will become the column. So in this way we get adjoint matrix. Write all the rows and columns. So adjoint matrix is the matrix which is transpose of cofactor matrix. And now the simple formula to find the inverse is A inverse is equals to 1 upon determinant of value of A into adjoint matrix of A. This is the formula to find inverse of a matrix. Just substitute the values and we get the inverse of a matrix. So A inverse is equals to 1 upon minus 3. We can write minus 1 by 3 also. And the adjoint matrix. So this is the inverse. This is the method to find inverse of a matrix using adjoint method. There we have to find minor, then cofactor matrix, take its transpose, adjoint matrix and use the formula. So A inverse is 1 upon determinant of A into adjoint of A. So in this way we can find adjoint this inverse by adjoint method.